Well, hello there guys, Mr. G here, and we are done with momentum and impulse. We did a couple of lessons, we did even an experiment related to momentum and impulse. So we're going to begin with the next topic, which is called projectile or vertical projectile motion. This topic is not so long, but it could be very tricky. So we're going to be speaking about a motion of an object in a vertical direction, which is moving either up or down. But without saying more, please watch the videos. I hope you enjoy. Write comment. We're going to make 2 experiments as well on this topic. We're going to calculate the acceleration due to gravity experimentally. We're going to find it out, and I'll see you next time. I hope you enjoy. Watch the videos. Thank you for watching. Mr. G here. Hello guys, Mr. G here, and this is another video for the grade 12. Now we're going to start a completely new topic after we finished a momentum and impulse. Now this is the next topic of the year, and is going to be vertical projectile motion. Okay? In everyday life we use the term projectile when we refer to bullets, fire guns or weapons, but in physics the definition of projectile is a different one. So let's first of all define what is a projectile. Alright, so what is projectile in physics? Now projectile is any object, and the word object is important, object that moves only under the action of gravitational force. So this object is going to be moving. It's important, it must move. Now this object is moving, and the only force acting on that object is going to be the gravitational force. Now the only force is the force of gravity, and therefore the only acceleration, or the acceleration of the object, is going to be the acceleration due to gravity. And the only acceleration of the object will be, right? So this is important to know. The object is going to move only under the influence of gravitational force, and therefore the object is going to be moving with an acceleration due to gravity, which is g. If the object is moving near the surface of the earth, then the gravity will be approximately 9.8 meters per second, or the acceleration due to gravity, meters per second, to the center of the earth is the direction. Remember, is a vector quantity. Right, so this is the introduction, the first part that we must know. Okay. Now, the motion of the projectile, which is where the only force acting is gravitational force, is going to be called free fall. Okay, so what is free fall? Now, free fall is any motion of any body or any object where the gravitational force is the only force acting on it. Gravitational force is the only force acting on it, and this is a motion. Note that the 2 definitions are very much the same. Projectile is any object that moves only under the action of gravitational force. This is an object. Free fall is any motion of any object where the gravitational force is the only force acting on it. Okay, so let's look at the following situation just for you to understand. Let's say, for instance, we're having a ball that is moving, and it's moving near the surface of the earth. Okay, so this one here is the earth. Okay, now the acceleration of this object is going to be always pointing towards the center of the earth. In this case, because we're talking about the earth, it's going to be approximately 9.8 meters per second square towards the center of the Earth. Now, I didn't show in what direction is the object moving. Why? Because it doesn't really matter. This acceleration is always going to be in that direction. Throughout the entire motion, the acceleration of the object will be equal to the acceleration due to gravity. It doesn't matter in what direction is the object moving. Now, let's for example say the object is moving up. It's moving up. Now, if the object is moving up, there must be a velocity acting on that object up, or there's no acting, velocity doesn't act. The velocity of the object is up. Velocity of the object is going to be up. For example, this is the velocity of that object at certain point. Okay, now if the object is moving down, then it's exactly the same. Now let's say the object is moving down, the acceleration is still down, and then the velocity is also down. Okay, could be small, could be bigger than the acceleration, it doesn't really matter. So this is the velocity of that object. Now the main point that we are making here is that the acceleration is always going to be downward. It doesn't matter in what direction the object is moving. Remember, only force is the force of gravity. I'm going to write it with a symbol there. The only force is the force of gravity, so the acceleration is going to only be the acceleration due to gravity, and it's always going to be downward. It doesn't matter if the object is moving up or down or horizontal. However, here we're going to only focus on the vertical motion, which is up and down, or vertical motion. Okay, now let's analyze this motion of the ball more into details. Okay, the whole motion of the ball just into details. For example, let's see the case of the same ball at different times. The ball was thrown up from the surface of the edge, or from any surface. It was thrown up and it moved up to a point, and this is the different times as the ball was moving up. Now the acceleration of that object is always going to be the same in magnitude and direction. It does not matter where the ball is. So this is the very first important thing. The acceleration will always be the same in magnitude and direction. It doesn't matter where the object is. Now, how is the motion of the object? Object will move up to a point, isn't it? Object will move up to a point, and then when it reaches that point, the object will stop and turn back to the surface of the earth. We call that point the maximum height. So this one here, for instance, we're going to call it the maximum height. This one is going to be the maximum height of this specific ball. So it was moving, and then when it's at the maximum height, stop moving and turns back to the ground. Now what happened to the velocity of this projectile? Now the velocity of the projectile will be upward, but the velocity of the projectile is not like the acceleration. It will be decreasing as the objects move up. So the velocity becomes smaller, as you can see there in the picture, up until the maximum height. At the maximum height, the velocity is going to be 0. So here, at this point, which is the maximum height, and that is important, we are at the maximum height, then the velocity is 0. Now guys, we're working with vectors. When we're working with vectors, remember we are to select the direction. So if we say up is positive, then velocity will be positive and acceleration will be negative. Right? This is important. If we say the other way around, down as positive, then the velocity will be negative, and the acceleration will be positive. Now, this is a very important point. This direction is a very, very important point, guys. So whenever we're working with projectile, as we did with momentum, we must always select what direction we want as positive or negative. Okay, so now let's analyze the same situation, but when the object is moving down, okay, as it's moving from the maximum height to the ground again. Now first, before we do that, let's write here moving up, because now you cannot really see in what direction is the object moving, so it's moving up. Now if we go into the moving down, so now if instead the ball is moving down starting from the maximum height or it's being dropped, then we need to know that the initial velocity here is going to be 0. In this case is velocity 1. Okay, so that one will be no velocity because it's at the maximum height or the object is being dropped. So this is because the object is moving from the maximum height or is being dropped. If the object is dropped, the initial velocity is also 0. So now the velocity will be pointing down and will be increasing as the objects move down. The acceleration, remember, is exactly the same. It doesn't matter if the object is moving up or down. So there you can see that the velocity is pointing downward because the object is moving down and it is increasing as time passes. Alright, so now we are going to do the same in terms of direction like we did here. If now we are moving down, it's a different motion, so it's a different complete motion. So now if we say up is positive, if up is positive, for instance, let's say somebody said up is positive, then the velocity is negative and the acceleration due to gravity is also negative, okay? Because they're both pointing downward and we say up is positive. If we say down is positive, then the velocity is positive and the acceleration is also positive. The acceleration is also positive. So there's a lot of information here. We are seeing how it works when the object is moving up and how it works when the object is moving down. Now this point here of the acceleration is the direction is very, very important, guys. Now let's look at the complete motion as the object moves completely from beginning up and down all the way, because there's important concepts I want to explain here. Now, there's important concept we want to speak here. This is the same situation, but now the ball is all moving in one motion, as it's moving up all the way and down all the way, right? And this is what we already explained. Acceleration is always down, the velocity changing direction as it go up is pointing up, but this when the object start moving down, the velocity changes down. Okay, so this is that we spoke already, is nothing new. But there is a new concept called time symmetry. Time symmetry. Now, this is a very important concept you are going to be using all the time. What this concept say? It say that the time to go up is equal to the time to come down. Now, this is a little bit tricky to understand. So let's say all the time to go up that we're talking from the initial to the final, if there is no interruption on the way, this time to go up must be equal to the time to come down all the way from top to bottom. This time is always the same if it's a projectile, if there is nothing interacting with that projectile. But I'm not talking about the total time. For instance, the time to go from this point to that specific point is also equal to the time that is going from that point all the way back to that one. Time down, sorry to the word there, let's fix that word there. So that is what we mean times up. It's not the total time, it's a time from one point to a certain point and the time from that certain point back to the same point. For instance, the time from there to there is equal to the time from here to there, but even more. even more. And I hope you're following me, guys. You have to follow me because you can get lost with all the pictures and the drawing. The time to go from this point here, to that point there, this point here to that point there, must be equal to the time as he wants from that point to there. So that is what we speak about times up and down. And this is a very important concept. The time to go up is equal to the time to go down. Very, very important concept. Okay? Because you are going to do it, or you're going to apply it and use it all the time when solving problems. But there is another concept that we have to learn here, and it's in terms of the magnitude of the velocity. Magnitude of the velocity, and I hope you understand here because the drawing is becoming a little bit too busy right now. Now, the magnitude of the velocity means that when the object is moving up and down, at the same point, the velocities will have the same magnitude. For example, and now I'm going to use a highlight so you can see it. At this point here, which is the same as the object moves up and down, the magnitude of the velocity right here at this point will be equal to the magnitude of the velocity right there. In other words, if the velocity here was or had a magnitude of 2 meters per second, here at this point the velocity will be equal to 2 meters per second. In terms of magnitude, the direction obvious, the one before he is up and the other one is down. Let's speak about the last one. For example, here at the bottom, when it reaches the ground and when it's leaving the ground, the magnitude of the velocity there will be the same. And this is hypothetical numbers. This is not real numbers. If the velocity here has a magnitude of 4 meters per second, so does it have it at this point. 4 meters per second. The magnitude will be the same but opposite in direction, and that is magnitude of the velocity. Guys, this is a lot of information. It is very important when solving problems. I'm going to stop here, and next video we're going to be speaking about equation of motion, how to apply the equation of motion. We're going to see few examples. I don't want to go too fast. This topic may be a little bit tricky, but thank you for watching. Thumb up, ask questions, subscribe, suggest. I like to interact with the learner, so don't be shy to interact. I will try to answer you. Thank you for watching. I'll see you next time. Mr. G here.